All right, well, welcome back. You know, you've come a long way already. We hopefully have a really good feeling about what equations are. Just like the kind of basic juxtaposition between equations and expressions. So we should have a good feeling about what equations are. We also, what you know, is how to solve equations through addition, subtraction, or multiplication, division, the getting of the zero or the getting of the one. That's the big ideas. Now we're going to kind of progress a little further. We're going to talk about some specific types of equations. The first one we get to is, and we spend a lot of time on, is called linear equation. So what a linear equation is, what it means, what you can get from it, and then starting to work with it. Right now I'm just going to introduce this concept to you. So just so you get familiar with what a linear equation is and what we can do with it. Next few videos we kind of decompress how to solve it. So some different techniques on how to solve that. We'll eventually get to how to deal with the distribution, combine like terms, how to deal with two variable, well, what looks like two variables, the same variable, but on different sides of an equation, fractions and decimals, but that comes later. So let's talk about what linear equations mean. So firstly, well, linear equation, it's going to be an equation. So you're going to have an equal sign in it. What linear means in this context of equations is in your equation, you should have just one variable. And that variable should be raised to just the first power. If you remember from one of the first videos we did, we had a power 2 and it gave us 2 answers. That's not going to happen here. So what that means are 3 possible outcomes. We're going to see, well, that outplay a little bit of what that power 1 does for us. So we got this equation. It's got one variable in it. It's raised to the first power. And we can always write them in ax plus b equals 0 form, or standard form for linear equations. That's what we're going to be looking at today. Now here's what we can get out of it. So what linear equations really give us, as the whole punchline, if you will, is really 3 possible outcomes. The first one is by far the most common. So most of the time, almost always, you're going to get exactly one solution. Don't let this pass you by. This is what we were talking about in the first video. When we had a power 1, we had 1 answer. Power 2, we had 2 answers. Power 3, we got 3 answers. Since we have linear equations, one variable to one power, we're going to get one answer almost always. Now, there are a couple exceptions to that. We can get no solution. It's rare. We can get infinite solution. It's rare. In fact, we deal with these later in a couple videos, and they look very similar. So this is something we're going to want to watch out for. You're going to know when it looks weird, okay? We'll get there. I'll explain it to you fully. Almost all the time here, very rarely, and dealt with later, here, no solution, infinite solutions. So what I want to do right now is I want to give you some examples, and we'll just walk through whether they're linear equations or not. If they are, we're going to write them in this form. I'll ask you what A is and what B is. That's basically it. Just to get a feel for what means linear equation and what doesn't mean linear equation. From there, we'll talk about solving in some future videos. So the number one, let's do this. Right now, some of you might be looking at it going, yeah, that's a linear equation. Well, it does have one variable. And that one variable does have a little power 1 right there. We don't write it, but it's not 0. That's a power 1. If it had a power 0, anything raised to the 0 power is 1, not a variable. So that would be a problem. So we do have a power 1 right there. We get 4x minus 7. But in order to be a linear equation, it first has to start as an equation. So right here, we would not have a linear equation. As soon as we do that, yes, we have a linear equation. In fact, this is already written in that form, ax plus b equals 0. If you had to look at this, and you notice that we have an equation, we have one variable raised to the first power, so by its definition, linear equation. If we write this in that form, what that means, all it means is you have your variable term first, term of the variables, and your constant term, if you have one, last, and then you have equals 0. So 0 is on one side. Your a here would be 4, not 4x, because a is that number, that coefficient of the number in front of x. A is that number in front of x would be 4. Your b would be negative 7. You go, wait a minute, I thought it was just 7. Look, the way that this works, this always takes for granted that's a plus. You go, well, wait a minute, what happens if you have a minus? this comes back from pre-algebra, but you can always write a minus as plus a negative, or adding the opposite of a number. So the reason why we would say A would be 4, that's pretty clear, and B would be -7 is because you could take the time to write this as 4x plus -7. It's the same thing as 4x minus 7. Not a difference here. It just allows you to look at the coefficient and the constant a little bit differently. So your coefficient, the number in front of x, would be 4, and the b part, the plus b, would be -7. Now, we don't really do that. We just look here and go, yeah, 4, -7. We just take the sign with the number. That's a very common thing to do. A term is always associated with a sign in front of it. So we're going to take that as a -7 here. Even though it looks like -7, I get it. We're kind of tricking the problem and going, well, because I could do this, I'm going to think of that as -7, even though it says minus. I get it. So that's your first exposure to a linear equation. Let's look at a couple more. Well, let's do this one. So let's ask the question, linear equation. How about more basic? How about just equation? What do you think? Is that an equation? Well, sure it is. It's got equal signs, it's got to be an equation. That's what we've been dealing with. I'm not going to change that now. Is it a linear equation? Well, the definition of linear equation means that you have one variable raised to one power. Here we do have one variable, but we also have another one. We can't have two variables each raised to one power for this form of linear equations. Now, when we get to graphing, and when we start talking about how to graph lines, linear equations in terms of graphing, yeah, we're going to have lines that are created by equations like this. But for solving right now, for solving for one variable for our linear equations, you got to have one variable raised to one power. This doesn't cut it. So let's change it. What if we just got rid of that? Is that now a linear equation? Well, think about it for yourself. Do you have one variable in an equation raised to one power? Sure. Now, is it written in that form? No, because we need a 0 for that to happen. What this standard form for linear equations means is that you have basically everything on one side and you have 0 on the other side. I'm not talking about solving right now. I'm talking about getting this form because a lot of times, a lot of your homework, your teachers, myself included, are going to want you to be able to manipulate equations to get them in certain forms. They help a lot with a lot of future math that we're going to do. So it's important to be able to do that. Can you get this to look like that? Well, here's where all our work with equations comes in. You see, I taught you before that you can do anything you want as long as you do it to both sides with an equation. So what if I wanted to move pieces? We get two options, really. What if I wanted to get this piece over here or this piece over here to move our terms? In order to move our terms, essentially what we're trying to do is we're trying to get 0 on one side of an equation. Now, there's a couple ways to do it. The first way, probably what most people would do is go, well, if I wanted to make 7 0, and that's +7, how would you get 7 to become 0? What would you need to do to 7 to get it to be 0? Let's think about it. Think about dividing by 7. If you took 7 divided by 7, would it make 0 for you? How about multiplied by 7? We get 49 if you multiplied. We get 1 if you divided. How would I get 0? With addition, subtraction, multiplication, division. The only way I can think of is, if I want to make this 0, I'd have to subtract 7. 7 minus 7 gives us the 0 we want. That's fine. You just need to make sure you do it to both sides. 7 minus 7, 0. Now this is important. If you haven't had pre-algebra in a while, that's okay. You can still learn this stuff, but you do have to understand one thing about it before we go any further. And we'll talk a lot more about it in a few more sections, a few more videos that we get to, but there's a difference between these two terms that we have on the board. There's variable terms and there's constant terms, and you may not combine them. So if one term has a variable and one term don't, you may not combine them. Just like here, 4x minus 7, you don't get -3x. that doesn't have an x. You can't combine those. For right now, you can just take that for granted if you don't know what like terms are. I will clearly explain them later. So we're going to have a lot of that in just a little bit about what like terms mean. For right now, leave it as, hey, if you have 4x's minus 4 xylophones minus $7, how much do you have? Well, those aren't an equivalent form of currency, I guess. If you want to pay someone xylophones, it's kind of weird. One thing I think of it starts with X. But you can't combine that. So 4 apples plus $3, how much do you have? I don't know. 4 apples and $3. You don't have 7 apples, you don't have $7. They're different types of currency if you're going to pay 7 apples. So here, we do not get to combine variable terms with constants. Here you don't either. How you write it is just negative 2x minus 7, since we can't combine them because they're not like terms. Oh wait, hey, that's it. Look, we got our form right there. What's your a? Think about your a, write it down if you can. So write what a is. Your a right now, if you've done this, should be negative 2. Write down what your b is, or at least think about it. Your b here should be 7? Negative 7. Negative 7. It should be the term with its sign. That's how we write these things in standard form. Now, I told you there was 2 options. You see, you could also do this. This is a little bit trickier. I don't know if it's trickier, but it used a little bit different thinking. Let's say we didn't want negatives. Could we write a linear equation different? Well, what if we didn't want to move the 7? What if we wanted to move the negative 2x? Now, I'm not solving. I'm not trying to get you to solve. I'm trying to get you to write this in this correct form. ax plus b equals 0. So we want a 0. What if I don't want to make this 0? What if I want to make this side 0? That's still okay. It'd still be that form. How would I get rid of negative 2x? Now, don't skip over this here real quick, okay? I'm not trying to get rid of the negative 2. I'm not trying to get a 1 here. I'm not trying to divide to get 1. I'm trying to get 0. The only way that we can, the only operations that even let us get 0 is addition subtraction. You can't multiply or divide by a non-zero number and get 0. So if we're doing this, we're going to have to add or subtract to get a 0 with our negative 2x. How would you undo all of the negative 2x to get 0? How would you make this 0? Well, if I owe negative 2x, I'm going to have to add 2x. So negative 2x plus 2x, the whole thing would give us 0. On the right-hand side, again, we don't have like terms, but we can write this in that form. 7 plus 2x, or 2x plus 7, because of the commutativity of addition, would give us the correct form. Here your a is 2 and your b is 7. Which one's better? It doesn't matter. They're the same thing. They're 2 different ways to write the standard form for a linear equation. So take your pick, whichever one seems right to you. I just need to make sure that you can look at an equation, firstly verify that it is a linear equation because it has an equal sign. It has one variable, and that variable is raised to the first power. That's a linear equation. That's what I want you to get. After that, I need you to make sure that you can write this in the proper form in some way and be able to identify a and b. That's pretty much it. We're going to do a couple more to see if you really get the hang of it. How about 3x squared minus 4 equals 0? Equation, sure. Linear equation, heck no. It has an x, it has one variable, but that variable is not raised to the first power. Right now, this is not a linear equation. Actually, it'd be a quadratic equation. That's later. That would be probably for most of you a different class. So this is a quadratic equation. If you eliminate the 2, that's where we get our linear equation. Now you have one variable, and it's raised to the first power. Yeah, I know, we don't write the 1. It's like writing the 1 in front of an x. You won't write either of those 1s. This would be 1x to the first power. So we still have our x, we still have it raised to the first power. That's one variable, the first power in an equation. That's a linear equation. Write down your a and b. If you can find your a and b, or think it, at least think it right now, what your a is and what your b is. It's in the correct form. You have ax plus b here. You'd have 3 for your a. You'd have negative 4 for your b. Done. That looks funky. The fractions already, goodness. If you ever have a fraction where your variable is in the denominator, the bottom of your fraction, you do not have a linear equation. So this right here, even though it's an equation, even though you have one variable, even though it looks like it's to the first power, we're going to get a little bit kind of beyond a little for a while. 9 divided by x, even though there's a little power 1 there, that's actually a negative exponent. A negative exponent, we can have that? Yeah, it's like crazy. This would really be, and if you want to fast forward to some of the videos in pre-algebra, we have it a little bit late. I don't know if we get there. Intermediate algebra we do, where we talk about negative exponents. That right there actually represents a negative exponent. So by its definition, if that's a negative exponent, it's not raised to the first power, it's raised to the negative first power. That's not a linear equation. So to boil it down, if you ever have an equation where you have a variable in the denominator, you do not have something linear. So we're not talking about that here. If you change this, which is not legal to you, you don't get to change it, okay? But if I gave you that, that would now be linear, where your A is 9, your B is -2. So let's do one more, because a lot of times students get confused between this example and what I'm about to give you. That one. So, well, why don't you think about it? Is it an equation? Sure. Does it have one variable? Is that variable raised to the first power? The biggest thing I want you to look at is this. The comparison of this example with this one. Are they the same? Do they look exactly the same? Here you said fraction. Oh, fractions are off the table, man, because we can't have fractions. That's not entirely true. We can't have a fraction where your variable is on the denominator. So think carefully about this one. If you were to make one fraction of this, watch the last video if you have to. Remember that video. Look back at your notes if you need to. If I made a fraction out of this, where would that y go? Would that y go to the denominator, or would it go to the numerator? Because if it goes to the numerator, we're good. We got one variable to the first power. Denominator is where we have the problem. This is the part where we move the variable to the numerator. So you could rewrite this as -2y over 5. That's fine. That variable on the numerator is okay. That is a linear equation. You can, in fact, leave it right here. What I don't want you to do is confuse this problem of having a variable on the denominator with this non-problem of having a variable being multiplied by a fraction. Just because you have a fraction doesn't mean that you don't do the problem, unfortunately. It'd be kind of nice. Like, fractions, F them. Get them? Fractions, whatever. But just because you have a fraction doesn't mean you're off the hook. If you have a fraction with a variable in the denominator, yeah, we're not talking about those. We are talking about linear equations. Yes, it's an equation. Yes, it has one variable raised to the first power. It's not on a denominator. It just happens to have an a that's a fraction. Could you take the time right now to write this in that form? It's just like the previous example. You can either choose to get this constant on the left or this term on the right, the variable term on the right. I'll show you both ways, but take some time right now and do that, okay? So option number 1, you should have already done this. You could subtract 3 from both sides. If you subtract 3 from both sides, they're not like terms. You have an equation. What you do to one side, you do to the other. To get 0 here, +3 minus 3 is 0. That's great, that's what we want. But you may not combine that. We just simply leave it -2/5 y minus 3, done. Your a is -2/5, the entire part, right before the variable. The b would be -3. Alternatively, the other way, you could add -2/5 y. If you add 2/5 y, yeah, you gotta do it both sides, it's necessary. Do it to both sides, but -2/5 y plus 2/5 y, hey, you're adding something to its opposite. You're going to get 0. On the right-hand side, you still don't have like terms, but we always choose to write our variable term first. That's going to stick with math for a long time. We almost always do that. There's some rare exceptions, but almost always your variables are going to be in order. So variables are going to be descending exponents. We don't have to worry about it now, but you're going to end with your constant. Either one of those works as long as you're able to identify that it's linear, that it's an equation, and you can get this in ax plus b form. Here your a would be 2/5 and your b would be positive 3. That's about all there is to it on identifying what a linear equation really is. Next time we're gonna start talking about how to solve some of these. I'll give you some very good kind of steps. Just the rule of events as we go through these. So I'll outline exactly what our steps are. We'll practice. This will be one of the longer videos. I'm trying to keep things about 15-20 minutes. But this will be a longer one, mostly because I want you to practice on the video, so you'll be pausing it a lot. We'll talk about how to solve linear equations when you have some distributions. So we'll talk about that.